Hey Internet, have you wanted to spray fluids into cavities but were afraid to try? Well, I have an answer for you. So we're going to talk about the pressurized spray gun I'm using, and mostly the nozzle, the 360-degree nozzle that I made to allow me to spray thicker liquids. So let's take a look at this. In my last video, part 1 of 3 of cleaning, rust removing, and painting the front frame rails on my 1800, I used this spray nozzle to spray into those cavities, and somebody asked me about it and where did I get it. So the gun, this is one of these pressurized deals I got off of Amazon for like 50 bucks. You unfortunately can't buy these anymore because of tariffs, I guess, but you can still get these in Canada or Europe. They're sold under a bunch of different names. It's a Unitool, but basically the deal is it's a pressurized undercoating spray gun, and the problem with it is it didn't come with a nozzle. It just came with a tube for spraying like wax in the cavities, and because I needed fogging and atomization, that's why I made this 360-degree nozzle. Okay, so all right, so what we're going to talk about is I'm going to go over really quickly. I'll do a review of basic nozzle physics, and then we'll get straight into machining on the lathe and the mill, and then that'll be it. So this will be a fairly short one. And then next time, a couple days or so, I will upload part 2 of my rust removal series, and that's actually using the Rust 911 to remove all of the rust. So here's a nozzle I've been using for a while. So it's just a brass rod with a hole in the middle with 6 individual wedge-shaped slits on the radially, and that gives us that nice 360-degree pattern. And yeah, let's go take a closer look at this. So why does this work? If we look at my nozzle, we can see there are 6 radial wedge slots. So 2, 2, and 2. Schematic here. Okay. When a liquid is forced through a narrow wedge-shaped slit, pressure energy turns into velocity. Classic Bernoulli effect. The fluid exits as a thin, high-speed sheet. The sheet spreads sideways because of the wedge geometry forming a fan. However, the sheet of liquid is unstable. Surface tension wants to pull that sheet back together, while air drag is trying to force it apart and agitating it above and below. So we end up with a sheet disintegration into millions of little droplets, and we get the process of atomization. The sharper and thinner the slit is, the finer the atomization, but that only works for low viscosity fluids. For higher viscosity fluids like the paint I'm using, that needs a little bit larger orifice, so hence the geometry I designed. So, okay, there is these sizes work, there's a really wide range of orifice sizes that these work with, and that's why I basically just made it up as I went along, because I knew that there's a really wide margin that this will work in. So anyway, let's go and take a look at the machining process. here's the setup I'm going to make this. So this is a Harig Grind All. So this is normally used on like surface grinders and stuff to like grind round parts. This is a super nice little spin indexer fixture. So it spins around and has this little locky thingy in there, and you can lock it at different angles. So it's super flexible, and you can offset this dealy-wag, and yeah, just a lot of really flexible what you can use this for. But yeah, I need to align this the nozzle in here, so I'm going to go ahead and center that with the with my test indicator here. But yeah, first, so this is a dovetail cutter. I'm going to use this guy to cut the little notches in the nozzle here. So yeah, I'm going to go and set up the phone, and yeah, so first thing we're going to do is center that deal in the this little offset thingy. All right, so I'll go ahead and set this guy to 0 degrees. There's a little angle indicator on the bottom. Okay, so all right, so I got that set to 0, and turn this guy on. All right, so I'm hearing that, so I'm going to set the RO to 0. Okay. Doing a 20 thousandths pass here. Okay, so there is our slits. Let's take a look at how this turned out. Okay, so I'm going to go run a drill through here just to deburr this, and I'll take a look at these holes. So I need to turn the shaft down on this, and I could use the chuck, the 3-jaw, but it doesn't fit super well with these slots cut in there. So I think I'm going to switch over to the collet chuck. There we go. We've got a nozzle. So I think what I'll do is I'll just chamfer this outside here to make it easier going into the rocker panel. And then, yeah. There we are. We've got a nozzle. So let's just clean this off a little bit and take a look at how this guy works. All right, so I'm going to go ahead and insert the nozzle into the quarter hose, and I designed this to be really, really super tight, so hopefully it fits, but I need to heat up that hose, and that's why I'm using the little lighter that maybe I made this a little bit too. Now it's going. Oh no, come on. There you go. Okay. There we go. That is a really super tight fit, so I don't want any chance of this thing getting popping out and getting stuck in there. So, okay. Nice tight fit. Okay then, well that is how I made this spray nozzle. Can you buy the, you can probably buy these. I didn't really look super closely at spray nozzles. I'm sure if you looked on eBay or Amazon or something, you can probably buy these. If anybody's interested, I can program the CNC at work to make these. Let me know, and then I will, okay, and then in probably next 2 or 3 days, I will upload part 2 of 3 of the front frame rail prep of these things, and that's going to be using the Rust 911. And then here is a couple little tease-me's of what it looks like now. Thanks for watching, and see you in a couple days or so.